Good afternoon, my dear students. Today we shall be dealing with turning point or stationary points. Turning point or stationary point. As the name suggests, a turning point on a graph is just a thing, a point where there's a thing, especially on curves. For instance, if I draw this curve, this is a quadratic curve. As my hand comes down, there is a particular point that there is a changeover, then my hand begins to go up. So the point at which there is a changeover is what is known as a turning point. You can also have another one. My hand goes up, it comes down. This is another example of a quadratic curve. There is a position somewhere here that as my hand goes up, when I reach there, there's a changeover, then it begins to go down. We have a cubic function. A cubic function. The graph of a cubic function looks like this. It has double turn. My hand comes down. There's a turn over here. Then it goes up. The rest point I reaches apex. Then I turn over. Or sometimes the cubic function, the upwards turn will be the first, like this, before it comes this way. So as my hand goes up, there's a turn here. Then it comes down. And I turn over. It goes up. So this is what is known as stationary points. The position whereby there is a changeover. Mhm. There is a changeover. The position or the point at which there is a changeover is what is known as a turning point. So here, somewhere here, and this curve somewhere here, in this cubic function, here or there, here or there. So the place where there is a changeover is what we know as the turning point or the stationary point. The turning point or the stationary point. We shall now look at types of stationary points. Types of stationary points. Types of stationary points. There are three types of stationary points. And number one, we have the maximum point. We also have another one known as the minimum point. Minimum point. Maximum point, minimum point. The last one we have is point of inflection. Point of inflection. These are the three types of stationary points, or otherwise turning points. We are going to illustrate them graphically to know how a maximum point should look like, a minimum point should look like, and a point of inflection, how should it look like graphically. So let's look at these graphs that illustrate the three examples of turning points. Yes, the three examples of a turning point can be illustrated using these graphs. Using these graphs. Let me call the first graph graph A, second one, graph B, the last one, graph C. Good. Looking at the first one, um, if I want to trace the first one, my hand comes down to the barest minimum, then I turn over and go up again. So I descend to a point which I refer to as the barest minimum, then I turn over. So this particular point is what we know as the minimum point. So this is a minimum point, or a minimum stationary point, or a minimum turning point. On the opposite way around, when I begin tracing this graph, my hand goes up to the barest maximum, then I turn over and come down. My hand goes up to the barest maximum, then I begin to trace down. So where the apex, where I reach and I come down, is what we call the maximum point. So this is a maximum point. This turning point or this stationary point is known as the maximum point. When I come here, I'm coming down. Then somewhere here, I meanders. I continue to come down again. Where I meanders but do not change over my direction. I was coming down, I do not change over my direction. That place is known as inflection. The point of inflection. The point of inflection. The point of inflection. Good. Good. So these are um, the three types of stationary points. This is how graphically we can illustrate them. But before we move on, there's a need for me to mention something. We have what we call stationary value. Stationary value. Stationary value. Good. The stationary value is the value of y at the turning point. Is the value of y. Value of y. So when I comes to my graph here, graph A. Coming to graph A, if I trace at the minimum point and then read the y value here, the y value I record here is a minimum value. Minimum value. So this y is the minimum value. If I come here and trace, the value I read for the y coordinate here is the maximum value. Maximum value. Maximum because the point is a maximum point. And here minimum because the point is a minimum point. But they are all stationary points, so I can call them stationary values. Stationary values. This similarly, I can have a stationary value here. If I trace the y-axis and read the value on the y-axis. Graphically, this is how things should look like. But quite unfortunately, we will not be using the graph to illustrate calculation involving stationary values and the types of stationary values. We'll be doing pure calculations using calculus differentiation. So we are going to look at how to apply our knowledge on calculus with regards to some of these calculations. I have taken my time to explain this because in your course of study, when you reach somewhere second year, you will be doing quadratic graphs, quadratic graphs, and its interpretation. You'll be sometimes required to find the maximum value of a graph, the minimum value of a graph, etc. And it is not different from what we will be doing in elective months, only that we'll be using calculations to obtain such values. But in the core maths where you're asked to interpret your graph, you'll be required to use the graph to produce those figures. It's the same thing. If your graph is accurately drawn, the results of the calculation will match that of uh, um, your graphical solution. So we'll now move on, pick a question, and learn how to perform calculations involving stationary values, stationary points, stationary values, minimum values, and etc. So let's now pick a question. Let's now pick a question. Let's pick a question. Let's look at the first question for today. We find the minimum and maximum point on a curve y is equal to x cubed minus 6x squared minus 15x minus 1. Good. Good. Now, we know minimum point and maximum point are all stationary values. They are stationary points, or otherwise, they are turning points. The minimum point, the maximum point are all turning points. There is one thing I didn't mention to you, and I'm going to mention it here. The gradient of any curve, assume we pick this curve, the gradient of any curve along the curve can be calculated using the gradient function. The gradient function is dy over dx. When I obtain the gradient function, for instance, for this question, it is 3x squared minus 12x minus 15. That is the gradient function. It becomes something like a formula that will help me to obtain the gradient along this curve at any point on this curve. Good. The only thing I need to do is that if I want the gradient here, let me even draw my axis, my ordinate axis. Okay. Sketch something like an axis. Okay. Y and x. If I want the gradient here, I only slot in the x value to calculate for the gradient. And the gradient at this point is the same as the gradient of the tangent. At the turning point here, good. At the turning point here, if I slot in the value of x here into this equation, I am going to obtain the gradient at this point, which is also equal to the gradient of the tangent here. I said the tangent is a line drawn to touch the curve. So the tangent at the turning point will be in this form. And we can see that this tangent is parallel to the x-axis. This tangent is parallel to the x-axis. Lines that are parallel to the x-axis to the x-axis have gradients of zero, have zero gradient, have zero gradient. Lines that are parallel to the x-axis have zero gradient. So it means the gradient at this particular point, will be zero. So at the turning point, in effect, means at the turning point, whether it is maximum, whether it's minimum, whether it's point inflection, at that turning point, the gradient is always zero. So write that somewhere in your notes. Add it to your notes. At the turning point, the gradient of the tangent, gradient of tangent is equal to what? Zero. Implies, which means I'm coming, my zero have wiped away zero. Okay, which means this also translates into the fact that at the turning point, at the turning point, dy over dx, the gradient function is equal to zero. Remember, the gradient of the tangent is equal to the value of dy dx at that particular place. We have done that in previous lesson. The gradient of the tangent is always equal to the value of the gradient function, dy dx, at the point of contact, where we have drawn the tangent. So if the tangent at the turning point is parallel to the x-axis and has a gradient of zero, it means dy dx at the turning point is zero. So take note of that. Okay. Now, let us use that knowledge now to find the value of the minimum and maximum point. Because we know that at the turning point, dy dx is equal to zero, let us differentiate the function to obtain dy dx. So dy dx will be equal to, differentiating the function is the same thing. This will multiply the coefficient here. The power multiply the coefficient, reduce the power by 1. Multiply the coefficient, reduce the power by 1, etc. The same thing that we've been doing. So this becomes 3x squared. 3 times the coefficient 1 is 1. And the power will reduce from 3 to 2. So 3x squared minus 12x. The power now becomes 1. Minus 15. The power there is 1. So the power on top of the x is 1. When I multiply the 15, it's still 15. So 15, and then the x become power 0, reducing the power by 1. And power 0, x to the power 0 is still 1. 1 times 15 is the same thing. So we'll leave it there. And differentiation of a constant drops. So this is our gradient function dy dx. The gradient function dy dx. Good. As we have learned, since we are looking for the minimum point and maximum point, at the minimum and maximum, the gradient of the tangent there is 0. It means our 3x squared minus 12x minus 15, which is the gradient function, is equal to 0. Then we use this equation to solve for x. This is a quadratic equation, so we employ all the methods that we know in solving quadratic equations, either factorization, using the formula, or completing the square approach, whatever it is. I'm using the factorization approach. I'll divide through by 3 to reduce the numbers. That's another technique. If you see that a quadratic equation is given to you and you're asked to solve, and the numbers are huge, and you can divide through by a common number to simplify the numbers, it is better so that the numbers become very simple. So you have x squared here minus 4x minus 5 is equal to 0. This becomes more simple to handle. Than it is not doesn't mean that you can't handle the 3x squared minus 12x minus 15 straight out. You can, but in mathematics, if there's always a simplest method, it is better you go by the simplest method. Okay, so it's better reduce the number. So solving further, good. We are going to look for two numbers. When they multiply, you get -5. But when they add, you get 5. The numbers are 5, -5, and +1. So we split the 4 into that. So minus 5x plus 4 plus x, 1x minus 5 is equal to 0. We factorize the first portion first, this side. We have x minus 5. That I'm factorizing s out. Then here, I'll factorize 1 out. S minus 5. Completing my factorization. S plus 1. X minus 5 is equal to 0. Good. Implies the values of x are -1 and +5. Good. Now, we have gotten the x values. It means the point that we are after is x, it is -1, y1. We have to go and look for a corresponding value of y. That's why I'm calling that one y1. And then 5, +5, y2. So we need to obtain the value of y when x is -1. The value of y when x is 5. One will be the minimum point. One will be the maximum point. How do you know which one is maximum and which one is minimum? That is what we are going to do now. If it is a graphical work, we can determine that by mere looking on the graph. We know the graph that opens up was goes up and comes down like this has a maximum point. This is a maximum point. And the graph that goes down and it comes up has a minimum point. This is a minimum point. That is graphically, you can see it on the face of the graph. Good. Good. Now, this is a cubic function. To the cubic function, it has two terms. So if you sketch the graph of x squared minus 6x squared minus 12x, it can either look like this or look like that. Good. So there's a 10 here, this is a 10, is a maximum 10, and this is a minimum 10. This 10 is a maximum 10, and this one is what? Sorry, this is a minimum 10, and this is a maximum 10. Good. So we're going to determine at x is equal to -1, is the point there maximum? Or at s is equal to 5, is the point there maximum? That's what we're going to test. So we're going to learn how to test that. There are two ways in doing that, but let's look at. I will employ the two methods. We employ the two methods. In mathematics, you need to know everything. Then, when you are in examination hall, you choose the best method that you prefer. But you must know all concepts. Sometimes you may not need it here. You may prefer to choose one method over the other. But you will need the idea somewhere. The other one you don't prefer, you may need that idea somewhere in solving the solution. Okay. You may need that idea somewhere in solving particular problem. So let's look at the ideal way of finding which one is maximum or minimum. To do that, um, you will do what is known as you will find what is known as second derivative of the function. Second derivative. Sorry, second derivative. Second derivative. Second derivative or second derivative. We'll find what is known as the second derivative. In fact, the second derivative is nothing so weird. Maybe those who attended the Scholars Campus school, the vacation class at the Scholars Campus, you were taught what a second derivative is. But those who are watching this video for the join this class virtually at home, you might not have done second derivative, but it's not something so weird that you have to get panicked. A second derivative, you can have even up to third derivative, fourth derivative, fifth derivative. When you say second derivative, it just implies when a function is given, you differentiate the function twice. Good. You differentiate, then the result that you have, you differentiate it again. Then you get the second derivative. The second derivative, the notation for the second derivative is written as d square y over dx squared. So when you see something like this, it means it's a second derivative. This is not the gradient function, the simple gradient from the first derivative. We know that when we differentiate the first time, we obtain 3x squared minus 12x minus 15. To obtain the second derivative, we differentiate this function again. This one, not the original function. We differentiate what we have obtained again. So my second derivative becomes d square y over the x squared is equal to differentiating this function. We are applying the same principle. The power will multiply this, reduce the power by 1. The power here will multiply this, reduce the power by 1. The constant term drop. Good. So this becomes 6x minus 12. So this is the second derivative. We can even further differentiate this function. When we differentiate this function, we obtain the third derivative. If we differentiate this, we obtain the third derivative. But we are only after the second derivative. So let's leave it here. Good. Good. Now, the value of the second derivative tells us whether the point is maximum or minimum. Pay attention to this. When you differentiate the function, and you obtain the second derivative, the square y over the x squared. If the value is negative, that is less than 0, a negative number is less than 0. If you slot in the x into this function and we obtain a negative value, it means we have a maximum point. Maximum point. On the opposite way, if we slot in the value of x into the d square y over the x squared, and we obtain a positive value, if the square y over the x square is positive, that is greater than 0, we have obtained that particular point is a minimum point. It's a minimum point. What about if it's exactly equal to 0? It is neither negative, it's neither positive, but it's exactly 0. The square y over the x square is exactly 0. Can you guess? I think your guess is as mine, good as mine. Good. When it's exactly 0, that particular point is a point of inflection. the point of inflection. So take note of that. So now that we have obtained our second derivative, which is 6x minus 12, we'll slot in our values of x and y. Sorry, x, the first value of x, second value of x, to see which of these 2 points will give us, will yield a maximum point or a minimum point, bearing in mind these guidelines that a maximum point has the value of its second derivative to be less than 0, which is negative. The minimum point has its second derivative to be positive, greater than 0. And when it's exactly 0, it is a point of inflection. So let's now test. Let's test. Let's test. We know our second derivative is 6x minus 12. Let me write them here again. The square y over the x squared is equal to 6x minus 12. When x is equal to negative 1, the square y over the x squared will be equal to 6 multiplying negative 1 minus 12. And this become negative 18. So since the square y over the x squared is less than 0, is negative, at s is equal to negative 1, the curve is maximum. Let's test the second one. When s is equal to 5 and x is equal to 5, we shall have the square y over the x squared is equal to 6 multiplying 5 minus 12. We are getting positive 18. Then we can also conclude that since the square y over the x squared is positive, otherwise greater than 0, at x is equal to 5, the curve is minimum. Curve is minimum. Curve is minimum. So we know the maximum point can be obtained at s is equal to negative 1, and the maximum can be obtained at s is equal to 5. Good. But the question is asking us to find the maximum and the minimum point. The emphasis is on the word point here. And the point should be of the form x, y, or in bracket. We have obtained the x coordinates. We need to use the equation to obtain the y coordinates. Then we declare the first one as the maximum point. We need to distinguish. We can't just write find the x and the y coordinate and leave it there, because they say you should find the minimum and the maximum point. So you need to distinguish which is your minimum point and which is your maximum point. So having calculated the y value for when x is equal to negative 1, we declare it as the maximum point because of the calculation we did there. Remember, when we tested using the second derivative, we came to a conclusion that at s is equal to negative 1, the curve is maximum. The curve is maximum. So, and then we'll also calculate the y coordinate. Calculate the y coordinate using the same equation when x is equal to 5. And we'll declare that one as towards minimum point. Good. I want to clear my working area, and we'll get space to to do the rest of the calculations. Okay, now let's proceed. We're now going to find the y coordinates. When x is equal to -1, or y coordinates, we just slot in the -1, so it will be -1 cube minus 6 into bracket -1 minus 15 to bracket -1 minus 1. I'm using this equation, the original equation. You can punch everything on your ES calculator. Okay, let me take my time step by step. This one will still give us -1. This one will tend to be positive. Sorry, there's a square here. Good, there's a square here. So here will still be there's a square here, 6x squared. So here will still be -6. Because this become positive 1 times -6. So -6. Here become positive 15 minus 1. And working further, we're going to have positive 7. So maximum point. Remember we said at x is equal to -1, the graph is maximum. And our maximum point is -1 for the x, 7 for y. Then similarly we solve for x when y is equal to, when x is equal to 5, our y value will be equal to 5 cube minus 6 multiplying 5 squared minus 15 multiplying 5 minus 1. Will give us 125. Then we have 25 here multiplying 6. So that will give us 150, and then 15 times 5 will give us 75. When we subtract everything, we are going to have -101. Hence, our minimum point is 5, -101. Now, this is the requirement to the question, but I want to give some little comment. The comment I would like to make is that, remember when we're dealing with the graph, I was giving you the graphical representation. I told you the minimum value or the maximum value is the y value when you trace the y-axis. So in this coordinate system, the minimum value is here. The y coordinate is the action of the minimum value. That is the y coordinate. This one is the action of the maximum value. The y coordinate here. So maximum. So this is -101. But if it is maximum value, that is 7. Remember, I told you there are so many ways you could do that. So if we didn't even use a second derivative to test which point is given as the maximum and the minimum point, we could have relied on the idea that since the y values are the values for the stationary point, we could have just slot in the value, perform the calculation, and pick this point as the maximum point, because 7 is bigger than what? -101, and this one as the minimum point. I want to repeat again. The value of the y coordinate If it's a graph, you at the minimum point you trace to the graph and read the y value, and that is the value of the stationary point, or the value of the minimum point if it's a minimum curve, the value of the maximum curve if it is a maximum curve, the value, the maximum value if it's a maximum curve. Let me even sketch a maximum curve. So like this, you trace the y-axis and read. That is graphically. But if you are performing calculations and you know the coordinate, of the minimum point, the coordinate of the maximum point, then you need to pick the y values, the y coordinate as the value of that particular turning point. Take note. And always read the question very well. Sometimes they will ask you the maximum point, or otherwise the minimum point. If it's a point in coordinate geometry, a point can only be represented by using the xy coordinate. Good. If they ask you, if for instance, we are asked to find the maximum or minimum value, if they use the word value, they are after only the y coordinate. So if you record your answer like this, you will not be given, because this one you are recording the point. This one you're looking for a value. So if you are asked to find the maximum value, you calculate the y coordinate and you declare it as maximum value. You are looking for the minimum value, calculate for the y coordinate and declare it as what? Your minimum value. Take note of that. But if you ask of a point, a point is always represented using the x and y system in this format. And take note. Sometimes they can ask you, find the maximum value and the value of x at which it occurs. Very good. So it's the same thing, but your presentation of the answer becomes different. So this is the maximum value. So if the question was find the maximum value and the value of x at which it occurs, I will record my answer as maximum value is 7 and it occurs at x is equal to -1. The same answers, but you are presenting the answer in different form as to the demand of the question. So we'll take note of that. I am repeating again, the question could have asked, find the maximum value and the value of x at which it occurs. We know my maximum value is 7, which can be obtained from the coordinate system -7, -1, 7. -1, 7. That's the maximum point. So if I want to answer that question, I'll record it at maximum value. I'm coming. The maximum value is 7 and it occurs and it occurs at x is equal to -1. The same values but different presentation of the answers. So take note. We'll look at a second question to let us understand the concept well. But before we go to the second question, I would like to highlight some key things we have learned so far. Now, let's look at some key things that we have learned. We have learned that one, the turning point is also known as the stationary point, as captured in our heading. So turning point is also stationary point, the same meaning regards to our discussion. We said a turning point or a stationary point can be 1, maximum, let me just write max. 2, can be mini, that is minimum. 3, can be inflection, point of inflection. Good. We have learned that a stationary point can be any of this. We've also learned that at any of these points, maximum, minimum, inflection, the gradient function dy dx is always zero. And for this one, you should be singing this because this concept will be carried along for some few weeks. We'll be doing application of the minimax. We'll be using it. So let it be at your fingertips that at the turning point or at the stationary point, dy dx is equal to zero. We also know that the stationary value is the y value or the y coordinate. Let me call it the y coordinate. That is better. Is the y coordinate. Coordinate. Graphically, you will trace and read. Graphically, you will trace and read on the y-axis. But calculation, if you perform calculation, you have your x and y coordinate at the minimum point or maximum point, the inflection point, then you are going to pick the y coordinate directly as your stationary value. And since a stationary point can be maximum, minimum, or inflection, the stationary value can be maximum value, minimum value, inflectional value. And those are the value of the y at their respective position at the turning point. So we'll take note of that. So these are the key things we have learned under this lesson up to now. We also learned, let me not forget, we are highlighting, we also learned how to find the second derivative. Those who didn't come to the vacation school, next time come. You will learn a lot. You've already learned what to call the second derivative. And today, those who didn't come, I've mentioned it, how to find the second derivative. The second derivative is just differentiating the function 2 times. If I differentiate it 3 times, I'll get what we call the third derivative, which is written as the cube y over the s cube. But we are not after this one. We are interested in this one for now. And the second derivative is used to test. Remember, the purpose of the second derivative here, now, it is for testing purpose. It does not give us any value. I've seen students using this as a gradient function. Please, this is not a gradient function. The gradient function is the dy dx. The purpose of this is to test the nature of the turning point. The nature, when I say the nature of the turning point, the nature of the turning point. You see the nature, they are asking you whether it is maximum, max, mini, or inflection. Inflection. The nature of the point can be any of these 3: mini, max, or inflection. And we learned that if the value of the square y dx squared is less than 0, that is negative, the point is maximum. If the square y over dx squared is greater than 0, that is positive. We have obtained a minimum point, mini. But if our the square y over the x squared is exactly 0, that's where we have inflection. Good. We shall be doing more questions. So when you do more questions, you understand some of this concept very well. So I will solve another question. So stay tuned for the next question. Okay, let's look at the second question. We are to Find the minimum and maximum points. It's like the first question of the curve y is equal to x cubed minus 3x plus 5. We know at these 2 points, our dy dx is equal to 0. Because they are turning points. Dy dx will equal to 0. And what is the value of dy dx? Let's find that one. Dy over dx. We have come to differentiate the function. Come 3x squared minus 3. The 5 drops. So our 3x squared minus 3 is equal to 0. Good. 3x squared minus 3 is equal to, since this is squared, remember it is a quadratic function and we need to differentiate and solve it quadratically. So to solve it, we can factorize. 3 comes out, x squared minus 1 is equal to 0. Dividing both sides by 3, we still have x squared minus 1 is equal to 0. Then this is difference of 2 squares, so it can be x plus 1, x minus 1, difference of 2 squares. That means my x values are negative 1 and positive 1. Good. Then we test which one will give us the maximum and minimum point by finding the second derivative, the square y over the x squared. When you find the second derivative, that means I am differentiating this function again. So to give us 6x minus nothing, this one drops. So when x is equal to negative 1, and the square y over the x square becomes 6 times negative 1, and that will be negative 6. It's in this at x is equal to negative 1. The curve is maximum. The curve is what? Maximum. And obviously the other one will also be what? Minimum. But let's check. The square y over the x square. Here to be 6 resulting in 1. We are going to 6. And we say when the second derivative is positive, it means what? We have minimum. So at x is equal to 1, the curve is minimum. Okay. Then we find it because they are looking for points. Look at it, they are looking for points. So we must find leave our answer in the coordinate system. So we have to go and find the y coordinate by using the formula or the equation y is equal to x cubed minus 3x plus 5. When x is equal to negative 1, we shall have our y to be y equal negative 1 cubed minus 3 times negative 1 plus 5. This becomes negative 1 plus 3 plus 5. When we sum all of them, what are we getting? Use your calculator, punch, and tell us the value. X is equal to 7. So maximum point. This is maximum point. Remember, it's a point. So my answer should be in the xy form, negative 1, 7. Then I calculate for the other one when s is equal to positive 1. And y will be equal to 1 cubed minus 3 times 1 plus 5. Good. When you solve this, you're going to get 3. Use your ES calculator. 1 minus 3 is negative 2 plus 5 is 3. And that because that is your minimum point, we say minimum point is +1, +3. As I said earlier on, the y values are always the values of the turning point. You can see the y value here is smaller than this. Good. So without even passing through the second stage here, after calculating for the values of your y, you can straight away determine which one is minimum and which one maximum. I'll get it. Because the value of the stationary point, I'm emphasizing this, the value of the stationary point is the y coordinate. I know why I'm emphasizing this because we'll come to the application of some of these things, and I don't want you to get confused. The value of the maximum point. We say the maximum value, we are picking the y coordinate. We say the minimum value, we are picking the y coordinate. Good. We'll be coming to application of minimax. Minimax. So that's why I'm emphasizing this. Now we'll solve the last question and I'll give you an assignment for you to try. So let's look at our last question for the day concerning stationary point. Tomorrow, if there's God willing and there is strength, we shall look at the application of these stationary points. What can we use them for? What calculations can we apply stationary points? Let's look at the next. Let's look at the next question. In this question, we are to find a stationary point of y equal 1/3 x cubed minus 2x squared plus 3x and identify their nature. By their nature, it means we should identify whether they are maximum or minimum. They are maximum or minimum. Remember, this one too, the question is asking of points. So it means it must be the xy form. Okay, we'll differentiate the function. dy over dx, the power will come and multiply 1/3, it become 1. And the power reduced by 1. So it become x squared minus 4x plus 3 is it. So that is it. And we know that at the turning point or the stationary point, our dy dx is equal to 0. So x squared minus 4x plus 3 will be equal to 0. It's a quadratic equation, so we have to solve it quadratically. Two numbers when you multiply, you get 3. And when add, you get -4. The numbers are -3 minus 1x minus 3 minus 1. When you multiply them, you get +3. But when you add them, you get -4. We factorize the first part. X comes out, we have x minus 3. The common thing here, we'll factorize -1 out. We have x minus 3 is equal to 0. So we have x minus 1, x minus 3 is equal to 0. So straight away, x is equal to minus a +1 or 3. Now, we need to identify the nature by finding the second derivative. So the square y over the x squared, we are differentiating this function. We get 2x minus 4. When x is equal to 1, we'll have 2 multiplying 1 minus 4 That will give us -2. It means at x is equal to 1, the curve is maximum because we obtain a negative value. In fact, this test is very important. Always don't try to jump the gun and slot in and pick the one. Because if it's a point of inflection, you might not know. Especially when they ask you to find the nature of the point. If the question says the 2 points are maximum and minimum, so you should find them. Once you have stated that maximum and minimum, you can straight away slot in the values of x and determine which one is maximum or minimum by uh, referring to the maximum or the values, the minimum maximum values. That's the y coordinate by not passing through this test. But when the question is open, like this, it says a stationary point. It can be maximum, it can be minimum, it can be point of inflection. And they have asked you to investigate the nature. Uh, this step is a mandatory requirement. It's a mandatory requirement. Okay, take note of that. Then we'll test when x is equal to 3. When x is equal to 3, we'll have our d square y over the s square will be equal to 2 multiplying 3 minus 4. And that will be positive 2. That's 6 minus 4, so it's positive 2. And when it's positive, we have what? Minimum. Minimum. So at x is equal to 3, we have the minimum point. The curve is minimum. Let me write the whole thing well. At x is equal to 3, the curve is what? Minimum. Minimum. Good. Now that we do that, let's go and solve for the corresponding values of y. So y is equal to 1 over 3 x cubed minus 2x squared plus 3x. When x is equal to 1, we have our y to be 1/3 1 cube minus 2 times 1 squared plus 3 multiplied 1 times 3 multiplying 1. So solving further, you can use ES calculator to get the answers. You will get 4 over 3. So since at x is equal to 1, the point is maximum, we say maximum point. We record it. Maximum point x coordinate first 1, comma 4 over 3. Now we solve for the minimum point. Solve for the minimum point, and that means y is equal to 1/3 3 cube, 1/3 3 cube minus 2 times 3 squared plus 3 times 3. Then solving, we have y is equal to 0 implies minimum point. Minimum point, we have x value first 3, y value 0. So that is that for question 2. We'll solve the last question. Okay, let me solve the last two questions. The last two questions, and then I will bring some technical questions so that we'll, we'll, we'll look at how to handle, a little bit advanced question. Let's look at some advanced questions a little. Some questions that will let you think. Okay, some questions that will let you think. Now, the curve y is equal to x squared minus ax plus b has turning point at 1 and 3. So we see here they have given us the values at the turning point, the coordinates at the turning point. Gone are days, they'll give you the equation and they'll ask you to find the coordinate at the turning point. But here, they are giving us the coordinate at the turning point, and they're asking us to find component of the equation because um, x squared minus ax, a is a variable for us to determine, and then a b is also a variable for us to determine. But this time around, we have our turning point. Good. It's the same principle. We know at the turning point, the y dx is equal to 0. But what is the y dx? Let's find the y dx. We differentiate the function. Here we'll get 2x. The power here will multiply the coefficient. The coefficient is a. So it is minus a. That becomes 0. It drops up. This is a constant term. They say a and b are constant. So, sorry, I think this question has a problem. Okay. B is constant, but a is not a constant term. So let's take that one out. This question has a problem. Just so simply, let's find a and b. B is constant, but a is a coefficient, so a constant. It doesn't start. Okay, let's proceed. So we have 2x minus a. Good. This is a turning point. Once it's a turning point, our dy dx, dy over dx, dy over dx is equal to 0. If the y dx is equal to 0, it implies 2x minus a is equal to 0. It means 2x is equal to what? A, not this one crosses. But note, at the turning point, at the turning point, x is equal to 1. We can get that from the question. Because the turning point is 1, 3. But the turning point, x is equal to 1. So we can slot in the 1. Can slot in the 1. So 3 multiplied by 1. Sorry, it is 2 multiplied by 1. 2 times 1 is equal to a. Implies our a is equal to 2. So we have solved for a, letter B. To solve for b, we'll come and use the original equation. Remember, this is the x coordinates and this is the y coordinates. So we can substitute that into the equation since we now know a. So the equation can now be written as a y is equal to x squared minus a. The a is 2, so I write 2x plus b. This is a point on the curve, so to satisfy the equation, so we put in slot in the value for the y, 1 squared minus 2 times 1 plus b. Good. Sorry, this mark is already there. We have 3 is equal to 1 minus 2 plus b. So we'll have negative 1 here. So it will cross the equal sign. It will cross the equal sign to become plus. So we have 3 plus 1 is equal to b. And then our b will be equal to 4. So reading the question initially, you may think that, hey, what question is this? But you are still following the same principles. Gradually, you see you get it. I will solve one question in that nature, and I will let you Now try some at home. So the last question I'm going to solve for this lesson. Stay tuned. Let's look at uh, the last question for the day, and I give you some exercise to perform. Now, the function f of x is equal to ax squared plus bx plus c has a gradient function 4x plus 2 and a stationary value of 1. Find the value of a, b, and c. Good. The gradient function has been given. This is the gradient function. Uh, it means our dy dx is equal to 4x plus 2. In fact, if a function is written like this, those who came to the, what do you call it, the vacation school, we were taught that the dy dx can also be written in this form. So I can say the gradient function of the derived function is plus 2. If it's a second derivative, we write it this way with a double bar, just like this. So take note. Those who came to the vacation school, they were taught all these notations. Uh, so here, because it's a function, I can decide not to write it as y dx. The same meaning. You write y over the dy over dx. Write y dy over dx purposely when it is in the form y is equal to blah 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 blah. But when it's in the function form like this, ideally, um, when we want to write dy, we want to write a gradient function, you write it in this form. But that doesn't spoil anything. But it is better you are told so that when you meet some of these notations somewhere, you don't you don't get confused. So I'm writing it this way, which is the same thing as the dy over dx is equal to 4x plus 2. But if I want to differentiate this function myself, my derived function will be this will multiply this. I have 2ax plus b. This will multiply this, and then the x will drop. That be the c will drop. This is what the question was given has given us, and this is what we did and we obtained. Uh, these are two identical equations. Ax plus b is equal to 4x, or is identical to 4x plus 2. We can compare these two equations since this is a gradient function and this is the function we obtained. This is a given gradient function, and this is a given gradient function we have obtained by differentiating this function. So they should be the same. So we'll compare. Comparing, I can say this portion is that portion. So I can say 2ax is equal to 4x. To find my a, you can divide 2 by x. Divide 2 by x, this goes up. 2a is equal to 4. Solving further, my a is equal to 2. Then comparing, I can say my b is also equal to this portion, this part. So b2 is 2. We have finished solving. We have finished solving for a. We have finished solving for a and b. Remember, this is a stationary point. Sorry, this is a gradient function, and they said the stationary value. The stationary value is 1. Since this is the stationary value, it means that the gradient at the stationary point is 0. So I can see, remember this 1, let me even ask this question. The stationary value of 1, what does it refer to? You know that it refers to the y coordinate. So take note of that. It refers to the y coordinate. This is a stationary value. Okay. But at the stationary point, we know y dx is equal to 0. The turning point, or the stationary turning point, or the y dx, dy over dx. And I said it can also be written as this with a dash, a mark on top like this, is equal to 0. Good. So since the gradient function is 4x plus 2, you can say that is equal to 0. And solving further, we have 4x equal to 2, and then our x will be equal to 2 over 4, and that translates into half. At the turning point, or at the stationary point, the value of x is half, and the value of y is 1. So it will be written something like this, 1. Remember, this is value. I still want to emphasize, that's why I was emphasizing previously. The value refers to the y coordinate. Okay, so we have 1. In order to get the c, we now have a complete coordinate for this equation. So we can substitute it. So 1 for the value for y. Then we know our a is 2. So 2 into bracket the x that we have obtained, half squared, plus b, which is 2, multiplied by half, plus c. So that we solve for. Oh, sorry, there's a little mistake. Let me correct it. When let's come here. Let me even use a different color so that you can see that. Let me use blue, deep blue. Okay, good. Good. Now, when the 2 cross the equal sign, here becomes negative. So take note of that. Here becomes negative 2. So we get negative half. Negative half. So we are substituting in negative half and not half. So take note of that. Take note of that correction. Good. So 2 negative half squared plus 2 times negative half plus c. Plus c. Good. If you compute everything here, we are going to get the whole of this. Use calculator. We are going to get. Okay, let me take my time gradually so that you get it. This will be 2 multiplying 1 over 4 plus. No, become minus plus negative times 2 minus 1 plus c. Then 1 is equal to, this will give us half. 1 over 2 minus 1 plus c. Let me continue down here. I'm continuing down here. Okay, so we have half minus 1 is negative half. So we have 1 is equal to minus half plus c. Minus half plus c. So my c is equal to 1 plus half. And my c becomes 3 over 2. 3 over 2. That's the value of c. That's the value of c. So that is the end of our today's discussion. And I want to recap what we have learned today. Recapping what we have learned today, I said that the stationary point is the same thing as the turning point. Stationary points are the same thing as turning points. And there are three types. I can combine the first two into two, called the minimax. Minimum or minimax. Minimum or maximum. Minimax. I prefer calling it that way. Minimax. And then we have the inflection. So these are the three types. We've learned that at these three positions, dy over dx is always 0. This one should be at the fingertip. It will run through our lessons for the week. Dy over dx is always 0. We also learned that dy dx in function form can be written f with a mark on top of the f like this. So I can see the gradient function. This is also equal to 0. Today too, we have learned that there's something called a second derivative. Those who didn't come to the Scholars Campus Vacation School, those who came, we taught them the second derivative is this. And the second derivative is used to test the nature of the turning point. When it's less than 0, negative, we have maximum, max. When you divide the square y over the x squared is greater than 0, that's where you have mini. And when it's exactly 0, you have inflection. If I want to write them in function form, then I can say f with double mark of x less than 0, I have maximum. Similarly, f with double mark. Second derivative, that's how I write the second derivative in function form. Greater than 0, minimum. F double mark x equal to 0, point of inflection. Then I have also emphasized that if the question requires for a point, your answer should be in the form x, y. If you calculate the x value and the y value and you leave them like that, you have not completed your work. You should bring them together to get in the coordinate system. But if the question asks of a value, maximum value, minimum value, then it is a y coordinate. The maximum value or the minimum value is the y coordinate. So these are the key areas of today's lesson. Now pause the video and copy the assignment that follows. Today I will not paste the assignment on the page. I would like to see those who have been watching the video. So I'll paste the assignment here, that those who've been watching the video, they will show those who've been watching the video. So that is that. So now copy the video, pause the video and copy the assignment. Do it and submit it by tomorrow. Tomorrow somewhere. Okay, tomorrow 6 p.m. Tomorrow 6 p.m. Okay. Do it and submit it by tomorrow 6 p.m.